Are we streaming?
1 second.
This is the mic.
I'm sorry, it's just going really slow.
What if nobody joins?
How? No, they'll join. How will people ask questions through Zoom or through text or something?
Yeah, so people who join in through Zoom can ask questions, and then people on YouTube can also ask questions. Okay, we are live on YouTube.
We are counting on you to read the questions from YouTube.
Yeah.
Got it. I got it.
Okay, and how do people join Zoom?
I shared the link out so people can join.
Okay, cool.
Yep.
Very good. We don't see if anybody joins, so you have to tell us that too.
I can tell you.
Did no one join yet?
We have Barry and Carrie have joined.
All right.
Okay, somebody asked a question on status. What's the sales pitch for Nimbus? Why should someone use it instead of other implementations?
Well, that's a good question. Ideally, it'll perform much better on resource-restricted devices. So it's going to be targeting a little weaker devices than the usual clients will. Think 6-year-old smartphones when Nimbus is released. So depending on when that happens, take 6 years away and it should work just fine on those phones. That includes also stuff like Raspberry Pis and so on. Current gen, maybe a little older, like Raspberry Pi 3 should be okay. And stuff like that. So resource-restricted devices and performance mainly.
And then industrial applications, like buying a ticket on a bus. Nimbus could save you the ticket.
Sure.
Okay, we have another question. Question 2. How did you measure / confirm that performance improvement?
We didn't yet because it's not done yet. We'll know more when we've completed more of the things. But the team is quite specialized in highly performant code, and Nim as the language is like very biased towards that approach. So that's kind of the goal there. But there's nothing to measure yet because ETH 2 hasn't launched yet.
Cool. Those are the only questions that we have come through so far.
Okay.
Another question. So what's the stage of the project?
Someone else?
At the moment, we are focused on following the development of Ethereum 2 as more and more things are formalized in the various specifications. We try to follow along. Our current goal is to work with the other clients together in a shared testnet. And this is expected to happen until just before the next DevCon. And following that, the next goal for all of the projects will be launching on mainnet. Nimbus is also a project has many other development directions as well. We are making progress on building our own Ethereum 1 client with the focus on resource-restricted devices, but this has been secondary for our team so far.
Cool. We have another question. Let's see. It says, how far away from launching on mainnet are you in the, oh my gosh, guesstimation? In your guesstimation. I've never seen that spelled out, sorry. So the question was, how far away from launching on mainnet are you in your guesstimation?
That's not something you can even guesstimate. It depends on way too many factors. So let's not put any even approximate numbers out. It's just wouldn't be right. It would be literally guessing on our end as well. We're keeping up with all the developments and we're in sync with everybody else. So as things progress, so do we.
Okay, our next question comes from.
Hold on.
Sorry, go for it.
I think it's like rather than looking at a date, it's more useful to think of it in terms of what needs to happen before a mainnet launch can happen. There's a number of tasks there that are arrayed after each other. So get the plan roughly. The spec itself was finalized like a few weeks ago, being audited for bugs and issues, and you could call it like an alpha release of the spec, right? And after the bugs and the issues have been weaned out, the foundation is looking into the spec itself. The client teams are looking to deal with all the matters around the spec, and that means networking, that means management, that means having a user interface of sorts, making things stable. There's a number of these little blocks that need to happen, which will lead up to this shared testnet that will participate in.
Okay.
Once we have all that, the shared testnet should ideally run for an extended period of time. Comfortable saying that this is a thing that is something. Finally, after that, after like a sufficient number of clients have declared that they're happy with their performance, with their stability, testnet itself works as intended for some period of time. That's what mainnet release will happen.
Okay, our next question comes from Barry. Can some of the tools and applications that Nimbus developed for F 2.0 be used today or in the future for scaling solutions with F 1.0, such as sidechains?
Yeah, it's in our development approach, we try to create libraries out of every single component that is needed for Ethereum 2. And this would involve cryptography, libraries about cryptography, about networking protocols, about executing the state transition of the beacon chain. So all of these components can be combined in various applications that somehow target or try to make sense of the Ethereum 2 world.
We're actually maintaining these libraries like to be as standalone as possible right now. And there's a site in progress that has some content already. If you go to nimbus-libs.status.im, there's a bunch of those libraries documented, and there's more content coming in one of these days, and those will help you get started with these libraries. So they're standalone in terms of you can use them if you're just building a wallet in NIM. You can use the cryptography side of these libraries to do the crypto stuff without having to depend on a node or something like that.
And I guess we should put a little bit of a disclaimer that this is the long-term vision, but we are certainly not quite there yet. And we have aggressive schedules that we must meet. So not everything is fully usable as a library.
Right.
Another interesting thing we're exploring is for JavaScript developers to be able to thing can be compiled to WASM, for example, and you can imagine that if you use some of the components of Ethereum 2, I don't know, that RISE or BLS segregation or other things, it's fairly easy to make
I'm sorry, you guys are actually cutting out. Could you repeat that, Jacek? You cut out.
All right, how about now?
Yeah.
All right. So what I was saying was that, like, thanks to new technologies like WASM, all the libraries that we're producing are also usable in the web context. So you can imagine that if you're building tooling around Ethereum 2 and you need to work with Ethereum 2 binary data, or if you need to work with Ethereum 2 cryptography in any way, shape, or form, the same things that we are using to drive the beacon chain and the Ethereum 2 applications that run on servers, you can also potentially run them in a browser, except maybe, the networking part or those parts that simply don't make sense.
Okay, definitely much better. We can hear you that time. All right, our next question comes from Carrie. What's the elevator pitch for the work you do? If you were giving it to a non-technical person, how would you explain in layman's terms what you do, what you work on, and what you're trying to achieve?
To a non-technical person, well, if that non-technical person just wants to know what Nimbus is, it's just one of the cogs in the Ethereum 2.0 machine that's required for that world computer to run. We're building a building block for Ethereum 2.0 in that it'll let you interact with this new blockchain in any way you see fit. So whether that's integrating it into like resource restricted devices, embedded devices, and so on, so that these machines that couldn't interact with the blockchain so far can now do so, or if it's to run your own node, to connect to the blockchain and send transactions, or if it's to just read it and analyze information, or just help the network, or to validate and earn stake in the proof of stake system. This will let you do all that, as will many other clients. So what we're building is one of the many options to connect to Ethereum 2.0 and to kind of maintain the vision of decentralized running of this new blockchain, so that there are multiple working client implementations. We all talk to each other, and the system is resilient against attack and against a single client failing, and so on. So what we're building basically is just a gateway, an entrance to the world of Ethereum 2.0 and to this new blockchain, and how people use that remains to be seen.
Yeah, I think it's simpler. Our vision is that everybody should be in the Ethereum world, and the easiest way for this to be done is if Ethereum is on your phone.
True.
Awesome. Okay, next question. From what from infrastructure side, the Nimbus beacon node, what from infrastructure side, the Nimbus beacon node fleet can help your work/research? Is it useful right now? If not, why? So I guess from an infrastructure side, the Nimbus beacon node fleet, can it help your work/research? Is it useful? If not, then why?
I'm not sure I completely get the question, but we are currently running our own testnet, which is restricted just to Nimbus clients. And I guess this is what can be described as the Nimbus fleet. We have running with 10 different servers connected in a small network. And obviously this helps us discover many networking issues related to latency, to non-synchronized state and non-synchronized worldview between these nodes. And this is essential part of what we do.
Plus, if you mean like other people who try to run our testnet as per the instructions, that is maybe not directly useful as it's running, but definitely useful as people report bugs, come back to us with feedback about both the experience and the problems that they've encountered. So definitely encourage people experimenting with our stuff.
Okay, let's see. The next question. How do you collaborate with other S 2.0 client teams in the ecosystem? Or do you at all? Is there shared knowledge across teams?
Yes, definitely. And the interaction is gaining more and more volume, I would say. Just recently, our team collaborated very closely with another team, Lighthouse, to come up with a specification for the Ethereum 2 networking protocol that will be targeted by the rest of the teams for this shared testnet that we talked about. So collaboration is very important between the teams at this point, because we all have to agree on the protocols and the behaviors of the client, so they can participate in the same network.
Okay, going back to the last question I asked about the the Nimbus Beacon node fleet. The question was from Jakob, and it was a fleet that he had made for the Infra Nimbus. It has 10 nodes, and so he was just asking, how can the Nimbus fleet be more useful to your research?
All right. And we speak with Jakob regularly when we need something.
I think one of the things that we talked a little bit about was that running on CIs upstream can sometimes be problematic. Actually, we might want to launch more testnets.
Jakob, actually, I'm sorry, Jacek, would you mind speaking into the mic? It's still a little bit.
All right, there we go. So, like, we've actually been talking a little bit about how this will grow when we have the shared testnet and like further along in the process. And rather than really a fleet of test, like a larger fleet, we might be looking into CI instead, so that we can start doing performance benchmarks on slightly more regular hardware than normal CIs run on. Slightly more consistent hardware, rather, because we're coming up to the point where we start looking at not only bugs and faults, but also at performance and at performance regression specifically, so that we know when changes in various parts of the application cause degraded performance. If we look at Ethereum 1, for example, there's this classic way of measuring that when things start performing badly, the uncle rate goes up. And in Ethereum 2, we'll have to be looking into similar ways of measuring, first of all, network performance, but also pure application performance. And developing the tooling and the graphing and the monitoring of these networks from these aspects is certainly something that we could use help with.
And I think Status as an organization as a whole could benefit if more hardware testing is performed on actual devices such as phones. And this requires building infrastructure for this kind of testing. And the Nimbus team is definitely interested in putting our own code sooner on the actual devices rather than later.
Awesome. All right. Next question. Why was NIM selected as the programming language for Nimbus instead of a language like Go, Rust, or C++?
We just had this discussion yesterday, actually.
Great. So you guys are fully prepared to answer it.
Oh, I guess the first aspect is that NIM just gets what it takes. I mean, it can produce a competitive solution in terms of performance, battery efficiency, and so on. Then the second answer that we came up was
well, if you look at languages, there are languages out there that tick the boxes, and sure, Rust and Go are obviously potential candidates. So when you start looking into a question like this, first of all, you have to narrow down the playing field to languages that are viable, right? That have the technical chops, and NIM obviously does. But the second thing is using language as a community building tool. You create an environment, basically, or something that people can identify with. And language is a very powerful tool for this. So in choosing our own language, we also create a distinct identity around which we can focus our work. And in so doing, also build up a knowledge base and a team that can center in on the core principles of the development, because they've been through the whole process of building it up from the very most basic building blocks. And together, like if we're building a network, it makes a lot of sense to have this distinct flavor around you, this I don't know, I hesitate to use the word, but branding, or way to express your identity, and the language then becomes part of that world. And I think this is sort of the non-technical reason why you would choose one language over the other as well. There, you want to enforce that what you're creating is unique in a way, and that by joining us, you join really a community of developers that have a particular goal and express themselves through this particular language.
There is something else that I'd like to mention. I'm very proud of our team. It's quite a rarity to have a team where everyone has been such a great contributor to open source before joining the team. And I guess one of the advantages when you are the first company to embrace a new language is that you get to pick the best and very passionate developers doing work in this language out there. That's not to be ignored.
Yeah, it's not every day that you get to develop a language.
Nice. Okay. On a more funny note, I guess, why is it a beacon node and maybe not a bacon node?
Because Jacek is vegetarian, and that's the only reason.
Yes,
Me
gotta
too,
be, right?
Jacek.
I
Okay.
refuse.
Next question is from Barry. If someone wanted to migrate a dApp on live F1.0 mainnet to F2.0 testnet, what are the steps they would need to take and possible hurdles to overcome?
First, they would need to develop shards. Then they would need to develop execution environments. And then they would need to develop various compilers of traditional languages like Solidity onto WASM or eWASM, and then to get to run it. On a serious note, it's just not an option. There's no way to run anything on E2, and it's not planned either for another while. The phase 0 that we're working on right now is just the beacon chain phase, which just builds up this chain on which you can become a validator and put your stake down to earn interest on it. And the clients are meant to just be able to synchronize on the information that exists on the beacon chain and on the state of these validators. Later on, we'll add on shards, which will be kind of like this hard drive for the content of the blockchain. And then later on, we'll have transactions, which include executing smart contract transactions and so on. So dApps are not planned for another while until the previous phases are complete and mature enough to progress further. So there's no rush. There's no need to rush at all.
There are two things more you could add to that. One is that like the first thing that will happen when we launch a proof of stake chain is that proof of stake chain will start providing security for Ethereum 1. And there's actually a work group to figure out exactly the parameters of that. But let's imagine that Ethereum 2 development stopped after the beacon chain is done. And if you look at it that way, then maybe the most interesting thing that has happened at that point is that we've launched a proof of stake chain. So that proof of stake chain could be used to secure the Ethereum 1 chain as it looks today, basically, which means that with nothing else developed, if the proof of stake concept, say, plays out well, you could just switch off proof of work in Ethereum 1. And we'd already have that as a, ready feature, even if we don't add, all the planned stuff of shards, of big bosoms, and so on. I also want to mention, like, if you're interested in what the DApp development will look like in the future, do get in touch. There's going to be events at DevCon 5 which invite DApp developers to communicate their ideas and sort of open a dialogue between these two researchers and DApp developers to make sure that expectations are fulfilled. Another little fun side project we just started was Nimplay, which is basically a smart contract development language that outputs WASM, which is one of the most likely execution environments in Ethereum 2. So basically, you can write your smart contracts now in a language which, if you've seen Viper, it's kind of similar. It's based on Nim. And you compile that straight to WASM. And again, we have a little demo up and running. We'll post a link somewhere after the...
Yeah, but it's already in the last development update. If you scroll down to other updates, there's a hint in there. You can check it out.
And this is on the Nimbus page that people can find this?
It's on the Nimbus blog. Yeah, you can just go to Nimbus page and click on blog.
Perfect.
So that's like a fun way to get involved in determining the future of development in Ethereum 2 and joining us in doing this language as well.
All right, our next question. What was the biggest or toughest technical decision you had to make while implementing Nimbus? Everyone can give an answer.
There's no decision yet.
We still haven't settled our.
Well, the toughest question is whether to use exceptions or not, I think. And we still haven't settled that after 1.5 years. This is just a language nerd speak. Yeah, like one thing that's challenging in a way is really working in an environment where the future is not certain. I think that has, because the target keeps moving, you're not always sure where to aim. Aiming right in the environment like this is not always possible and not always easy. So you have to use a lot of good sense and feeling in order to know what to do. And obviously then negotiating this with the researchers and the other client teams also becomes unpredictable. You never know when a new interesting technical idea might simply wipe out, a month's work. But nonetheless, like when you look at it at face value, at this early stage of research, what you really need to do is make sure that you don't get stuck on your previous ideas, but rather remain open to new solutions that where even though the sunk cost might be significant, the right thing to do is to follow this new lead. And that's I think one thing that's certainly been hard to navigate over time. I don't know if who wants to add something.
Okay, that's it.
Okay, cool. All right, jumping to the next question. What's the worst part about the Ethereum protocol spec?
Wow. It's pretty good, actually. But
Long variable names.
I guess one challenge for us was that the Ethereum spec is developed in a way that is very mathematical in its nature. The specification is written in a programming language, but if you try to translate the spec precisely, you end up with a not very optimal implementation. And so it has been a challenge for us so far to make this decision whether to stray away from the way the spec is written or to work around the performance issues that arise from time to time.
Right, and I would say that trade-off has changed over. Where? Somewhere here. That trade-off has changed over time as the spec has evolved, and I can actually. Before there were several more objectionable parts of the beacon chain spec, which is this phase 0 spec that has been completed that Jacek was referring to before. And those have been largely fixed or ameliorated, which is good, but it also meant they were by removing these or sort of addressing these points, even though there was some cost, what that one had to always anticipate that as a spec went, say, from version 0.4 to 0.5 to 0.6 to 0.7 to 0.8, each time there was always this question of how much to invest in optimization in exactly what Zahari is kind of referring to, this kind of deviating from the spec as written for performance reasons, because you know that a lot of that work would be wiped out. A lot of it would be because they would just change the underlying mechanism to obsolete that optimization versus how much do you just kind of do something that's fast enough now and you know gets us to the next spec version. And to wrap up this answer on my end, I'll just say that that trade-off has changed considerably now that things have solidified, or 0.8, I guess. And the thing is, this is supposedly the final version of the spec. There will be no more major restructuring. So it's much safer now to go all out on optimization, even than it was 3-4 weeks ago. So.
And in general, you can say there's a delicate balance between having a long-term vision, for example, how the networking protocol should be defined, and then having this short-term goal that all of the clients will be able to interoperate. So it's not easy to come up with a spec like Ethereum, but I think the teams are doing a good job.
I'd actually mention one more thing here is that when you're working with the work in progress, the rationale behind many of the decisions has not settled yet. So you're not really sure why you're doing certain things necessarily, and that's something that you discover through the process of working through it. And then as you discover new things, that rationale might change slightly. So my hope is that, like in this period now, once things have settled down, is that we also produce more documentation which is less dry and doesn't just say like run this code, but also goes into like for example, the economic reasoning behind certain decisions and so on. And I know that this is work that's being done, and this documentation and is being written. So for anybody that will implement the spec in half a year, hopefully they will have a much easier time of knowing why they're doing it and what exactly they have to do. And that's perhaps something that the spec has been lacking, like up until this moment.
Okay, and there's a follow-up question from it. So what is the hierarchy of values when making decisions? Performance, stability, speed of development, aesthetics of code, and so on, in what order? So what is the hierarchy of values when making decisions?
All right, so speaking at least for the protocol code that I've worked with, I aim primarily at some kind of robust debuggable kind of correctness when feasible. And in particular, there's this trade-off with optimization where it can become less transparent, the intent, less debuggable. And so it's important to me to set up code that is what one can do is essentially disable sort of the trickery, disable the things which, so let's say if I add things which cache some of these values which need to be frequently used because it is quite a quasi pseudo mathematical spec, as much as Python pseudocode can express that. Like that caching is can be bolted on, and if that goes wrong, that's not a fundamental part of the code base in a sense. That can be removed. So if there's any doubt of the correctness of that specific optimization, for example, and this doesn't apply to all optimizations, but then I prioritize that lower than having sort of all out performance, in some sense lower than having some baseline correctness. One reason for this I would observe is that the point of these clients don't have to run infinitely fast. We're not doing something like throwing out there video encoding where it's like you really just want to run, every additional incremental speed improvement has tangible benefit, or there are other situations like this. The whole network runs on a clock, let's say a 6-second slot clock. It doesn't matter if you run in, to some extent, power usage perhaps, but and there's other considerations, network latency, et cetera, but let's say broadly, abstracting a bit from that, if you complete your tasks if you're every 6-second tasks in 0.5 seconds, 1 second, or 2 seconds, does not matter, right? So because the network is synchronized. And so there's really no ROI in over optimizing, or certainly prematurely optimizing. Now, because we are aiming for resource restricted devices, and because developing on PCs is obviously more convenient, and the feedback, the tools are better, there is value in trying to comfortably be faster than 6 seconds on development platforms, so that say on a Raspberry Pi we still hit 6 seconds, but that's what the extent of that. So I would say I won't try to kind of enumerate every one of the potential hierarchy items that the question contains, but I would say broadly correctness and robustness and flexibility to a degree, and then adequate performance. Performance is a threshold, it's something to satisfy, not maximize.
I would say that security is probably the most important thing. A system such as Ethereum has to be secure, otherwise it doesn't work.
Yeah.
And then correctness, I would put quite high on this list. And once we have this, maybe then we can talk about efficiency. And correctness usually comes through trying to make things simpler. But once we have this, we will target efficiency because that's our long-term goal.
Perhaps it has also changed a little bit over time. So what you have to understand about developing Ethereum 2 right now is that the spec was written without any tests. And like the only thing you have to go by in terms of correctness at that point is that No, first of all, that it does more or less what you think it should do. So that, you know, if you have a bunch of people voting for the same block, then that block should eventually become the canonical head of the chain. And then the other thing that you have to go by is kind of, sounds silly, but like visual similarity between the spec and your own codes. You can't really go too far outside of that. And then what's happening right now is that tests are being written, like state tests, that verify that all the little pieces of the spec and the state transition function as they should. And once you satisfy those correctness requirements, well, then obviously you can start deviating in more substantial ways from the spec, for example, in the name of performance or whatever it might be.
Okay, so Jakob would like to know what level of understanding of mathematics someone would need to understand the specs. As in, how complicated is it?
Oh, it depends on how deep you want to dive. I mean, if you care about cryptography, there's plenty of number theory that you could have fun with. But if you want to have intuitive understanding, I mean, I don't feel a lot of math is necessary. I mean, high school math is completely enough to give you intuitive understanding.
Yeah, I guess. I'm not sure I would classify myself what level of math or how much math, but I would say the other sort of what if one wants to understand what the background assumptions of the spec are. So I think it's important to distinguish between here, just literally reading and on a superficial level understanding the spec. There's a thing where there's a check for whether a vote is something called a surround vote, and it's part, as part of the Casper FFG conditions. And so in things like that, if you literally reading the spec, you don't need to know any math. It just shows, it literally says, specifies what that check is in very direct terms. But in terms of why, but in terms of being able to go back and sort of understand why does the spec include this? What, how, there's an underlying proof of if it's, depending on whether something's a surround vote or a double vote, what does that mean about that vote? Well, that involves reading a mathematical proof. It's, so like that. And so that's another direction in which one can go. But if you don't want to, you can just read through the spec, and none of those things per se show up in the spec, but they are the background of the spec. They are why it is the way it is.
Talk about the cryptography.
All right, so that was actually that was the last questions that was asked. So I guess I can open it up if anybody else has any additional questions who's on the call. People can submit additional questions in the #status channel or on YouTube if there's any other additional questions that people want to ask. I'll give some people a second. If not, maybe you guys can tell us what's next for Nimbus or what's like upcoming, some exciting new things.
Oh, just yesterday we spent the day planning our next goals, and the shared testnet is what we'll be focusing, and this involves starting tests with first of all with Lighthouse. This is one of the other clients, and then developing, introducing Ethereum 1 testnet in our Nimbus only testnet, so people can interact with the validator contract and deposit test it to become validators. And then we will improve a lot of our infrastructure for monitoring the testnet. We are planning to create a help page. When you see how many nodes participate, like you get some of the status, we'll probably expose a little bit of logs, like what's going on.
Yeah, focuses on interoperating with other clients right now. So getting that up and running in time. I mean, not in time, but kind of laying the foundations for that to go well on the event that all the ETH2 teams are planning to go to. So like this hangout where everybody's going to collaborate actively and make that happen in time for DEF CON so that everybody has like this communication between clients going. And in many elements of Nimbus, this is kind of the overarching priority. Like along with other stuff, we're looking heavily into making it all work nicely together with everybody else.
Cool. Will you guys share out all this stuff when you guys are done? Like meeting and everything's kind of done?
We have an issue. If you navigate to our beacon chain repo, you will notice on the issues page, you will notice that one issue is pinned at the top, and this is our roadmap. It was put together quite some time ago, but what we did yesterday is we just prioritize things. So you'll see some items crossed out. This doesn't mean that we have given up on them or something like this, but just that they are not our immediate priority right now.
I think one interesting development, fairly recent development as well, is that we've taken the steps to create a fully P2P implementation in them. And this is the sort of base layer infrastructure technology that from a communication point of view is very interesting because it allows really anybody to communicate with these other languages that were mentioned before. If you're building your own application, for example, your own peer-to-peer application, you will have from NIM available the capability to talk to Rust, talk to Go, and so on over a peer-to-peer network. And that's obviously useful outside of Nimbus as well. And this is a collaboration that we're doing together with Protocol Labs and the Ethereum Foundation. So expect more of these kind of useful public good libraries to be created as part of Nimbus. And perhaps that is also one of the things that's kind of exciting because all the stuff that we do is out there for people to consume, and whether they want to put it in their custom hardware or in their own software project in some way, shape, or form. Ethereum 2 kind of drives a lot of these technologies that are very recent, but also very interesting from both from a networking and a cryptography perspective.
Okay, cool. And we have another question. What paths are being explored for decentralized file storage, specifically for storing large content such as DApp, front ends, or media files?
That is another thing in the works. So we've been looking into this issue a little bit, and it's a project that's nascent right now in the planning stage. The idea would be that with a shared communications layer like libp2p, and with development from the protocol team, which is Oscar and Dean, and the people that they're collaborating with, we offer, first of all, Ethereum 2, second of all, private messaging, and then finally a project that will start a little bit later, a decentralized file storage. And the plan here is to collaborate with Swarm and bring sort of Swarm to Nimbus as well, offered over this one network, so that if you're running Nimbus, the full thing, you can get access to both storage, messaging, and obviously Ethereum then. Or if you're building an application, that you can pick and choose the various components that you're working with. But I would stress that this is early stages, and we're sort of trying to figure out exactly how to shape those projects and integrate them into a whole. And why we're doing this? Well, it is also a way to approach adaptive nodes and just these light clients and restricted devices that perhaps need to interact with a remote storage more than a powerful and beefy server. So expect to see more on this in the coming months.
Awesome. And you guys are in Berlin for Berlin Blockchain Week. So you guys, some of you are speaking on some panels, correct?
We're going to be at Berlin.
Okay.
And there's a panel there on Ethereum 2 development in general. So make sure to catch us there.
Awesome. All right. And so we have 10 minutes left. And the last question that was asked was actually not a Nimbus question. It's a personal question for every person. Okay. The question was, what are your favorite alcoholic drinks? Each team member, please answer.
Gin tonic.
It said each team member.
I prefer beer.
Oh, well, that changes over time, you know.
I like alcohol fine. I have a strong favorite though. All of them. Good. I like that answer. All of them.
Solid answer.
Jaggermeister.
Wow.
Maybe cocktails, but if there are no cocktails, then whiskey and beer.
What a variety, right?
Yeah, such a variety. All right. Well, that was our last question that was submitted. Do you guys have any closing comments or statements you'd like to make before we end?
Thanks for being here and asking questions.
And see you
Cool.
soon.
All right. Then, yeah, that ends our little AMA here. So this will all be shared out again. So for anybody who didn't catch it, we will share it out.
Awesome. Thank you, Johnny.
Yeah, no problem. Bye, guys.
Bye-bye.
See you tomorrow.